Hi folks, and welcome to the Spring 2016 offering of ISBIT 212 materials. If you're watching this video, obviously you realize we'll be doing most of this course, at least the lecture portion, online inside Canvas. What I wanted to do with this video is introduce sort of the course itself, and then introduce a little bit of the Canvas particulars, and then we'll just move in and jump right into the course topics. So if you've been an ISBIT major with us for a little bit, you've definitely seen this picture before. Let me go ahead and swap out. We've been talking about componentizing, or turning large systems into smaller components. And as you know, what we've been studying is how those components interface with each other. And we've been studying systems that are based on components that interface through energy connections, through information connections, and then now through material connections. So if you've been with us, you know that ISBIT 112, our processes class or our physics class, was all about energy. ISBIT 211 was all about instrumentation and measurement, or information. And now we're going to be specifically talking about material. And we'll be talking about different classes of materials and how systems interface with each other based on moving material back and forth. So it's definitely a concept that you've seen before and definitely familiar with. Talking about the concept map for the course itself, this course, ISBIT 112 or 212 materials, what I wanted to do was provide a very brief overview of where we're going before we jump in and head in. So this course will be sort of lumped or moved into three different areas. The first area, which as you can see down here is sort of a spoiler highlight, will be evaluated in Exam 1. We'll be talking about how we actually test materials, and then specifically we'll be talking about what types of theories are behind materials, what makes a metal, what makes a polymer or a plastic, and what makes a ceramic or a glass have different properties than all the other materials that we're going to study. So that's going to take a few weeks to take a look at, and it's sort of a great stopping point for us to get set up and get all the vocabulary we need to take a tour of different materials as we progress through the course. So that'll be Exam 1. And then Exam 2 happens to have three areas. Let me get my goofy face out of here. We'll be specifically talking about three different areas. Metals, and you'll be seeing a little bit, especially throughout the course, you'll find out why we specifically talk about ferrous metals and non-ferrous metals. We'll be talking about plastics, or polymers and elastomers, and we'll be talking about ceramics and glass. And these are our big three materials. And then we'll have plenty of time to sort of take a break and take exam 2 after looking at this information. And then our third and final sort of component of the exam, which will be covered on the final exam, as well as comprehensive of the other materials as well, are these three ideas, and that's composites, adhesives and coatings, and then fuels and lubricants. So that's in about a minute or a minute and a half, that's a really brief overview of what we're going to be talking about this semester. And what I wanted to do is sort of go back very, very quickly and talk about what these things look like. So mechanical properties testing, this is what our laboratory will be about for the first few weeks of the course. We'll be taking different materials into the lab, and we'll be using specified and specific equipment that we have to test materials, to test how strong they are and how stretchy they are, how bouncy they are, and all kinds of other fun stuff. And these are the types of vocabulary words that we're going to be covering and learning about. Again, I can just read them: tensile, bend, hardness, fatigue. These are different types of adjectives that you use, or material scientists use, to describe different materials. Regardless of what they're made out of, these are the generic adjectives that we use to describe them. And then towards the end of this module, we'll be talking about non-destructive tests. And that's where, say you wanted to find out how strong the glass is on an iPhone. Well, you could test it by pushing on it until it breaks. But then, of course, you have a broken screen. You have a broken iPhone when you're finished. So a lot of these tests up here in the top of this bubble are exactly that, destructive tests. You test them until the product fails, but sometimes you just want to test things and get an idea of how strong they are, or get an idea of how great they are before you continue to use them, like testing the strength of your teeth. You don't want to break your teeth. You want to test them, or at least examine them and find out whether they're doing well or not. So we'll be talking about that for a little bit. And then before we launch into the different areas of different types of materials, we're going to be talking about some theory. Most notably, this probably comes out of chemistry. We'll be talking about what makes materials behave the way that they are, what makes a material strong, what makes it not break if we're going to use a special material for the screen of an iPhone. We'll be talking about the different structures and the different material specifications, as in what types of materials would you use if you were to specifically or to specify a brand new product. So if you were going to design a new phone or a new iPhone, if you're at Apple, you can specify what types of materials and what their properties should be. So again, that's sort of going to sum up our first module for our first exam. And then we're going to take a walk through the big three. Everybody knows, if you've had courses from me, 3 is a very large theme in science. Specifically, it's a very large theme in integrated science. Our first theme is going to be talking about materials that are metals. Ferrous, we're going to be finding out pretty quickly, happens to be an older Latin name for iron. We're going to find out as we work through this material why we talk about ferrous and non-ferrous, or iron and non-iron based metals. You'll notice if you're familiar with a lot of these terms here, these are the types of metals that you see either every day, or you read about them, or you've worked with them. We'll be learning about all these different metals. We're going to move away from metals and transition into plastics. That's the word that's typically used. But of course, the official name for a plastic material is a polymer material. We'll be learning why that is. We'll be learning about polymers and their very closely related cousins, elastomers, or stretchy materials. We'll be talking about, what makes them stretchy and what makes them plastic, and where they come from and how they're processed, and all kinds of fun stuff. And then we're going to round out the big three. They're different types of materials with ceramics and glass. We'll be talking about these different properties of the ceramics and glass. And then that will round out our big three for the different types of materials you can choose from. And then that sort of sets us up for our second exam. So then we'll have that. And then after we're finished with our second exam, we're going to take those big three. It's not often that you use material that's just pure something, like aluminum foil. Let's use pure aluminum for aluminum foil. But past that, once we get into an iPhone, or once we get into us, then what we're talking about is we're talking about mixtures of these different materials. And in material science, we call them composites. So we're going to be talking about different types of composites, specific examples of them, and then what they're used for. And then after we learn how to talk about and recognize and process composites, we're going to specifically look at different materials that are used for, and using the word specifically again, for specific purposes. Obviously, an iPhone is used for all kinds of purposes, including making phone calls and accessing the internet. But there are other classes of materials other than smartphones that are used for specific purposes. And one of those properties happens to be adhesives. These are materials that are sticky. And coatings, these are materials that are sticky and have been stuck to something to usually protect what's underneath it. So we'll be talking about different types of adhesives and coatings. And adhesives and coatings are made out of the entire big three. We'll be talking about metals and polymers and ceramic adhesives and coatings. And then we'll be talking about composites of all those as well. And then we're going to round out this semester. It sounds like, gosh, it's the first day of class, and we're talking about rounding out the semester. We'll be talking about specific materials that are used as fuels and lubricants. So some materials are specifically used because they do carry energy. We burn them like gasoline and petroleum. And then other materials are used specifically because they are slippery. So in the case of adhesives, where we use materials to stick two things together, we use lubricants to keep two things or many things apart. So we're specifically talking about oil inside your car, or grease on a squeaky hinge and the like. So we'll be talking about all these different things one at a time.